Okay, so we have been using um, tables, graphs, and equations to represent relationships. Now we are going to take it one step further, and uh, we're going to look at a relationship with a table and a graph, and we're going to use the graph to extend the pattern and to really answer a question about that relationship. Um, so we can see here in this problem that we have a pattern with these tiles. So there's a blue tile in the middle, and the blue tile is always surrounded by um, four orange tiles, two yellow, and two green. So whenever there's a blue tile, there's 8 more tiles around it for a total of 9 tiles. And so if you have 2 blue tiles, then you're going to have 18, just like you can see in the table here. 2 blue tiles, 18 total tiles. 3 blue tiles, then that's 9 plus 9 plus 9, 27 total tiles. And every time we add a blue tile, we go up by 9 more. So we're going to look for a pattern here, and we're going to use the graph to help us find that pattern. And then we are going to also use the graph to extend that pattern. When you find a pattern and you use that pattern to make a prediction, or to figure out, in this case, what would be the case if that pattern continued, that is called inductive reasoning. And that is one of our math vocabulary words for this lesson. So we're going to use some inductive reasoning to figure out what is the total number of tiles in a figure with 8 blue tiles. Okay, so what I've done here is I looked at the table and I made this graph. First I looked, and the first thing I had to do was I had to label my axes. So for my x-axis, I looked, okay, the blue tiles is my x, and that's going 1, 2, 3, 4, 5, and I need to go up to 8. So I went up in steps of 1. So I went 1, 2, 3, 4, 5, 6, 7, 8, and I got enough room down there to accommodate all those numbers. You'll notice I didn't number 1 or 3 or 5, and that's okay. Anybody who wanted to could figure out that right here is where the number 5 should be. And it also makes my graph a little bit easier on the eyes. It's not too crowded with a bunch of numbers. So that part was pretty easy, but then I had to figure out this y-axis, and how big of steps should I be taking there? What kind of scale should I be using? And so I looked here and I saw 9, 18, 27. I thought, well, those are going up, pretty quickly. It seems like by the time I get to 8 blue tiles, I'm going to have 60 or 70 or 80 tiles. And that was kind of the assumption that I went with. And so I made this axis go up in steps of 20 here, with some smaller grid lines at 10 and smaller grid lines at 5. But I numbered 20, 40, 60, 80, and I drew those lines in. And I think that should be good enough to get a fairly accurate answer to this question. All right, so now that I drew my graph, I made my axes, then I had to put these points on. And so I went to my table. I said, okay, when the number of blue tiles x is 1, then the number of tiles y is 9. So when x is 1, y is 9. So I went to 1, and then I went up to, well, I don't have a 9, but I went just below where 10 would be. Next, I went to 2, and I went up to 18, which is just a little bit below 20. Then I went over to 3, and I went up to 27, which, let's see, 20, 25, and then just not quite up to the next line, but kind of in the middle between those two. It's 27. And then 36. So x is 4, y is 36. So I went to 4, I went up to just over 35. So that's where I put 36. And then 5, 45. So I went 5, and 45 is actually one of the lines that it's a little bit hard to see, but it's there, that I have. So that was right at an intersection of grid lines, which is always nice when you get to put points right on those grid line intersections, because it means you can be very accurate in where you're putting the point. Okay, so now I have my points on my coordinate grid, and the final thing that I need to do is I need to look at that graph and see if I notice a pattern, and then I need to try to extend that pattern at least over here to where the 8 is, so I can see where would it be if we had 8 tiles. So when I look at these dots, I think, well, it looks like they're making a line. Now, this isn't going to be a perfect line, or it's not going to be a complete line. I don't know if this will let me. What I really should do here is I should draw a dotted line, but I think that technology is going to prevent me from doing a dotted line. So my line's going to be solid, and I'm going to draw it straight through the middle of every one of those dots as I can. And you'll notice that I started at 0, 0. I made the assumption that if there were 0 blue tiles, there would also be 0 of total tiles. Okay, so that's my line. That's the pattern that I saw. And I've extended it through the dots, and now I'm going to try to answer the question, what is the total number of tiles in a figure with 8 blue tiles? So I go down here and I look at 8, and I trace that up until I get to my line. So based on the pattern I saw, I think that this should be, let's see, here's 60, 65, 70. It's a little bit below halfway for the next grid line, so I'm going to say it's like 72. So my extending my graph has led me to the, well, my line disappeared, or my dot disappeared. That was weird. I don't know why that happened. That I would get 72 total tiles. Or for an x of 8, my y value on this line is 72. I'll just kind of put this in here again, and hopefully it stays this time. Oh, the other thing I wanted to mention, the reason this should be a dotted line is because if you think about this, this line is going through points that don't really exist. So, like for example, right here, we might have 21.3 total tiles. And in this situation, that isn't something that could really happen. You can't have, or at least, I don't know, I guess you could cut the tiles, but this pattern doesn't really give us the idea that that's something that's likely to happen. And so a dotted line here that would show only 1, 2, 3, 4, 5, 6, that would be more accurate to show that it's not going to really fill in all of those possible spaces. Okay. So that is how you would extend a pattern with a graph. And then next we're going to look at how you would do that same thing with an equation.